Hello everyone, this is Mrs. Crandall and I am going to be reviewing factoring trinomials by grouping. There are two things that I want you to pay attention to before we look at the first example. Actually, let's go to the right here where it says ax squared plus bx plus c. And you'll see that I've drawn a big X diagram, and then what I've done is I've put a times c up here at the top, and I have a little multiplication symbol up there, and then I have b here on the bottom with an addition symbol underneath it. And then these two spots are going to be the unknown numbers that we are trying to find. It's kind of like a little puzzle. So I'm going to actually set this up for the first problem, but before we do that, I want you to pay attention to this piece right here, which says always check for a greatest common factor. Before we start any problem, that is something that we need to be looking for. So if I'm looking at my terms 3x squared, negative 2x, and negative 5, there isn't a greatest common factor other than 1. So I don't need to worry about it for this problem. So let's go ahead and do our diagram. And I'm going to put a times c at the top. A is 3 and c is negative 5. So if you multiply those two, you get negative 15. And b is going to go on the bottom. And now what we're trying to figure out is well, what numbers multiply to negative 15 but at the same time add to negative 2. And those two numbers are going to be negative 5 and 3. It does take a while to get the hang of this. So my suggestion to you, if you're struggling with coming up with the numbers, is you list out all the pairs of numbers that multiply to 15. So that would be 1 and 15, and then 3 and 5. And then from there, it's easy to think about, well, what two numbers, and including the negative sign, would add possibly to negative 2. And you can see right away that 1 and 15 that's not going to be it. So it has to be 3 and negative 5, or 3 and 5, and then the 5 has to be negative in order for it to add to negative 2. Okay, so what these two numbers represents is that these are going to become the new coefficient of that middle term. So I'm going to bring down the 3x squared, I'm going to bring down the negative 5, because that is not changing. What is changing is this middle term. And I'm actually going to rearrange this. It doesn't actually matter, but I'm going to put 3x first. 3x is positive, the 3 is positive, and the 5 is negative. So you need to make sure that the variable is attached to those numbers. The reason why, again, that this works is because if you take 3x and negative 5x and combine them, you get right back up to negative 2x. So mathematically, this is all well and good. Now what we're going to do is you're going to draw a, we're divide these two, divide this polynomial into two groups. And how I do that is immediately after the second term, I draw a vertical line. And what we're going to do is we're going to factor out a greatest common factor from this first group. The greatest common factor, they share a 3 and an x. So we're going to factor out the 3x. And you can think to yourself, well, 3x times what equals 3x squared? And that is x. And 3x times what equals 3x? That's 1. Or essentially what we're doing is we're dividing these two terms by 3x. The greatest common factor between negative 5x and negative 5 is going to be negative 5. Now this sign, if this sign is negative, you're going to factor out a negative. If it's positive, you're going to factor out a positive. So we're going to factor out a negative 5. And when we divide these two terms by negative 5, we get x and we get positive 1. And these two factors match. That is exactly what we want when we are factoring by grouping. If these two factors do not match, then you have one of two options. Either you made a mistake somewhere, or what you are factoring isn't actually factorable. So since I have a match, I'm good. What we're going to do is that it represents a number. X plus 1 is a number. We're going to factor that number, x plus 1, out. And what that looks like is you're actually dividing each of these terms by x plus 1. And when you divide each of these terms by x plus 1, what you have left is 3x minus 5. So there you have it. We can check this answer by multiplying it back out, and we would end up, when we combine like terms, we would end up with the original problem. So remember how I said earlier that we always need to check for a greatest common factor? Well, here's where it comes into play. Another thing to keep in mind is that if your leading coefficient is negative, you should factor out a negative. It just makes it easier, the factoring easier. So 6, 16, and 8, they are all divisible by 2. So I'm going to factor out a negative 2. And divide this term by negative 2, you get positive 3n squared. Divide this term by negative 2, and you get negative 8n. And divide this term by negative 2, and you get positive 4. So the negative 2, we're kind of done dealing with that, but sometimes we forget to put it in our final answer. So I'm going to go ahead and just rewrite it here at the bottom where I'm going to put the final answer, and then I'm going to just focus on this trinomial that I have here. So I'm going to set up my problem very similarly to before, where I find a times c, which is 12, and b, which is negative 8, and we're going to find the two numbers that multiply to 12 but add to negative 8. And this is going to be negative 6 and negative 2. So that means that this middle term here is going to become negative 6n and negative 2n. So I'm going to bring down the 3n squared. I'm going to rewrite negative 8n as negative 6n and negative 2n, and bring down the plus 4. So the only thing that is changing is that middle term. Go ahead and split it into two groups and factor out the greatest common factor from each group. So the 3n is what we're going to factor out, and that's going to be n minus 2 that's left. And then factor out a negative 2, n minus 2. And so our final answer, again, that negative 2 came from the very first step. So the common factor is n minus 2. And then on the outside, we have 3n minus 2. And the negative 2, the n minus 2, and the 3n minus 2, that is your answer. It does not matter if the order of these two are flipped around, it means the same thing. Remember, 2 times 3 is the same thing as 3 times 2, so it doesn't matter what order it's in. The last problem, we actually have two pieces that we need to factor out. We need to factor out a constant because we can see at the very least these numbers are even. And then we also have a variable. So a to the third, a to the second, and a. We can factor out an a from all of these terms. So 2 actually isn't going to be large enough, because if I factor out a 2, that would give me 8 here, that would give me 30 here, and 50 here. So all, again, even. So I'm going to factor out a 4. The greatest common factor, I believe, is going to be 4a. So when we factor out a 4a from the very beginning, you can divide each term by 4a. So you'd have 4a squared. This is going to be plus 15a, and then divide this by 4a. This is going to be minus 20. I'm going to put the 4a on the bottom. I actually am pretty notorious for forgetting the greatest common factor. So this is something that I do so that I remember to put it in my final answer. Because if it's missing from your final answer, it's not right. All right, so here, a times c, 4 times negative 20 is negative 100, and then 15. So this is going to be, so the factors of 100, 1 and 100, we have quite a few of them here, 2 and 50, 3 is not going to work, 4 and 20. Okay, that's what I need. 4 and 20, 20 has to be positive, and then oh no, that's 5 and 20. What am I doing? I messed that up from the very beginning. Hold on, I gotta fix this. See, this is real-time mistakes here, guys. Some of you are like watching this and being like, oh my gosh, she made a mistake. Is she gonna catch it? Yes, I did. I caught it. So 4 times negative 25 is negative 100. Oh, but it still works out. Huh, that's funny. Okay, I don't know what I'm doing. I think doing math past, it's like 7 o'clock right now, so my brain is 7 p.m., so my brain is not working as well. Okay, so we're still dealing with 100, and actually this still works out great that this has to be, so wait, 1 and 100, 2 and 50, 4 and 25, 5 and 20. There we go. That's what I need, 5 and 20. So 20 has to be positive, and 5 has to be negative. Now, remember that this is because it needs to multiply So negative 100, 20 times negative 5 works. It has to add to 15. And something to keep in mind is that there is only one right answer here. There's not multiple possibilities. So we found the correct, numbers. Anyway, so 4a squared plus 20a minus 5a minus 25. And again, I brought the 4a down here, so I'm just ignoring it. Split it up, factor out a 4a, and you get a plus 5. Factor out a negative 5, and you get a plus 5. So good, we have a match. Final answer is 4a, a plus 5, and then 4a minus 5. So there we are. Okay, just one other example that I want to give you. All these examples have been expressions. So sometimes you're going to be given a problem where it says solve by factoring. So factoring is the way that we get to a solution to a variable. So you're going to see a lot of similarities here. But one thing that you have to realize is, first of all, when it says solve by factoring, we are dealing with an equation. So it has an equal sign. And then the other thing is we need to set the entire equation equal to 0. So that means that the first thing that we need to do is we actually need to add 4 to both sides. So we get 4n squared minus 17n plus 4 equals 0. Then we are checking for a greatest common factor, and I don't have one other than 1, so I can go ahead and set up my problem. So this will look really similar. 4 times 4 is 16, negative 17 goes on the bottom, so that's going to be negative 16 and negative 1. I'm ready to rewrite. So negative 17n is going to become negative 16n minus 1n, or minus n. Split it up. Greatest common factor is 4n. So we get n minus 4. And then we're going to factor out a negative 1 here. So we always have to factor out something from that second group. And we get n minus 4 when we do that. So we have n minus 4 and 4n minus 1. Now notice that I was really good about putting this equals 0 each step. It's really important that you make sure you include that, because the last piece here is that to actually get the solution for n, so to get n equals, we have to set each of these pieces equal to 0 and solve. Remember that this only works if 0 is on the other side, because 0 has very, very, very special properties in math, meaning that if you take two numbers and they equal 0, it is guaranteed that one or the other or both are equal to 0. A 0 could be here, or a 0 could be here, and this could be 1,001 over here. It doesn't matter, or 0 could be in both places. That equals 0, but it's a very special property that only 0 has. So what we do is we set, since we have two pieces, they are factored. They are two quantities multiplied together equal to 0. We set n minus 4 equal to 0 and get 4. And we set 4n minus 1 equal to 0. Do some algebra. And we get 4n equals 1. And then finally divide by 4. And we get n is equal to 1 over 4. So we have two solutions here. N equals 4 and n equals 1/4. Now notice how different that looks from these problems where we had actual factors as our answers. Here our answers are solutions to the variable, but we got those solutions to the variable through the method of factoring. Okay, that's it for this video, and feel free to watch the other ones that I have posted.